Okay, recording started. Okay, so we are going to start designing a web crawler or actually a Wikipedia crawler. Both actually are similar because they both are like a huge in size. Like there's a lot of content present. So we'll be doing the design, and we'll be starting from a very basics of what a crawler is. Basically, once we most of the time, this is a very popular question: design a web crawler, but I think before even someone starts designing the web crawler, people need to understand what a crawler is. What are the famous problems? I mean, some very good problems that a crawler faces. And this is a very this crawler, right? It has been studied for like 20 years. Even Google did that. That is how they started. So we'll go into the basics of a crawler. We'll see what problems comes when a crawler starts doing its work, and then we'll go into the basics, then we'll see the problems, we'll solve them. These papers they also have a very good design, and most of the systems implementation use that. And then later on at the end, we'll do the design from scalability point of view. Basically, we'll be given 1,000 commodity machines. We'll be given 1,000 commodity machines with like 4 GB RAM and like very limited like disk space. So we'll see how to design then, because this was the exact question that I got in my lift onsite. Okay, so basically let's start from what a Wikipedia. So basically, let's say this is either a I mean, does someone else want to explain what a crawler is, or how does a crawler start? Anyone? If someone knows what a crawler is, how does it start?
With a seeded list of URLs.
And what does a crawler is supposed to do? What is it, and where is it used? So basically, a crawler is basically used for building a search engine, right? So basically, let's say you want to build, Google wants to build its own search engine, or let's say, right, and they want to keep crawling the websites, and they want to discover the content, and they want to index those that content. For example, for the search engine, so you put in cricket, you put in football. They want to list all the documents that contain football, and they want to show it in some order, right? So that is the classic case where a crawler is used basically for search engines, right? And so as Sue suggested, a search engine like a web crawler always starts from a seed URL. Okay, so basically, let's say you have some to start a crawler, basically let's say you have URL 1, URL 2, URL 3. So to begin with, let's say this is some queue. Okay, so now what will it do now? So what will the crawler do now? Give me the steps.
You get the child URLs or the embedded URLs in each of the pages that correspond to these URLs. And
no. So even before that, so basically this is like so basically there are two ways. So this is the queue. So either you do DFS or you'll basically do a breadth first search. You extract the first URL from your queue. So basically this is seed URLs, right? It doesn't have just one URL. It will have some, let's say, basically your main goal would be to give the seed URLs to be some URLs that will help the crawler navigate the content the most, right? I mean, you don't want to give it a URL which is like ankurkotari.com, like no one is pointing to my website. I'm not pointing to any other website. I'm just a blog, right? So that is what I mean. Your seed URL has to be that way. So let's say you first get the first URL from the queue. Yeah. So next thing, Sue.
Visit the page.
Pass the page.
You didn't download the page. You have to download the page first.
Yeah, first you got to visit it, then you download it.
What did you say? Do you have to?
You have to visit it first, and then you can download it.
Visit it. Okay. You said visit, right?
Yeah. You have to navigate to it, right?
Yeah,
once you navigate to it, you're gonna download. You can download the HTML. right?
Yeah, download the HTML.
Once you have the HTML, then you parse it. And the three things you're going to be interested in, well, three areas you'll be interested in are one, URLs that are parsed in the page you downloaded, meaning they're linked to other pages, the HTML itself, and then any references in the HTML to JavaScript or CSS.
So can you repeat that? Like I'll write it down. So basically, you
three
pass the
things-
content per URLs.
Yeah, you parse the content for the page, right?
Uh,
The first thing you're going to do is get all the URLs on the page.
get all
Yeah.
the URLs.
Right. Then you're going to save the text somewhere, right? I'm assuming you're gonna need the text for a search engine. And then you're also gonna additionally download well, your JavaScript and your CSS will be included as URLs or relative URLs. You gotta parse both relative and absolute URLs. So yeah, get all the URLs, save the text, okay? Once you're there, then you're gonna have to separate those URLs which point to another page versus those URLs which point to content.
Yeah. So basically, I think I mean to put it in a way, I mean we can do one thing like okay, you're saying that you get the text, you get the URLs, and then on basis of some criteria, you basically you're doing URL filtering, right?
Right.
So you do URL filtering and you put only the valid URLs back to the queue.
Right. But before you put them back in the queue, you need some way of making sure you're not visiting a page you already visited. Otherwise, you're gonna end up in a loop potentially.
Okay. So what about, okay, so basically you're checking for duplicate pages.
Yeah.
Okay. What about so let's say I visited crickinfo.com, right? I have already seen it, right? Will I what should I do with crickinfo now? That same URL.
Basically, you need some sort of way of looking up whether or not you visited it, right?
So basically, you would be asking I mean, so basically, this content of any website, right? It keeps changing, right? So basically, and you want to, I mean, in the queue, you can actually put the URL back into the queue, right? I mean, so that I mean, even for Google, right? They keep, I mean, they keep parsing the same page again and again, not quickly, but after some point of time to see that the page has changed or not. So basically, I
Yeah,
think
so you can keep when you last parsed it, and then depending on the delta between when you queued it and when you parsed it,
yeah,
if
so
it falls within right.
yeah, so basically, I think when you said check for duplicate pages, you get the URL again. You check has the content changed from the last time it saw. Basically, you get into the hash map or some database. You see what is the like you use shingling and everything to see if has the page changed. If not, then you again scrap it, right? You again download it and check the contents. So basically, visit the URL again. If the content has changed. Are these steps clear to everyone?
Ankur, I have a question.
Yeah.
I guess I'm a little confused about it because last year I got asked this question, WebCrawler, but instead of designing it, it's more about coding it. And in that situation, I don't need to download the web page. Am I right? I just have to figure out the duplicates and stuff. And that was so. Is that not the similar approach here? We are here looking for content, or more about the URLs that, like for example, we talk about the www.apple.com, and inside that we can visit with the help and other like a blogs or something like that. Those URL we are interested in, not the, and I'm a little confused there.
Sorry, I mean, I know I'm confused with your question now. So you're saying, I mean, I have visited apple.com. I mean, the first time I visited apple.com, I get the page.
Mhm.
right? And after let's say 10 days, I again, I mean, past apple.com, I've received all the content and all the URLs. I put it into my queue. I also open apple.com at the end.
Yeah.
So after that, I again get apple.com, and this time the page
Mhm.
has added, let's say, a few more blogs or links. So basically, I have
Yeah, I
to
mean, I don't. I mean, that was something. I'm just trying to understand that because I don't remember my question exactly, but it was about the web crawler. But and I do remember I don't need to download the content in it because I just have to get the URL. Once I get the URL, then I have to figure out the child URL and duplicates and stuff like that.
How will you
But
get
I don't remember. That's why I'm saying I don't remember exactly that part. That I got the, like, for example, first URL I got was www.apple.com, something inside the iPad and so on, something like that. And from then that onwards, I have to do that. I mean, it's been a while, so I'm just trying to understand. I hope I don't make confuse others.
I think the point is you go to apple.com, right?
Uh-huh.
And then you see what links are available on that page, right? And for each of those links, you go down and parse those pages. You do
Yes.
the same thing.
Actually, I think there's one more way, right? I mean, using HTTP GETs, you can just using headers, you can get the content length.
Exactly. That's what I did it, that get your, like, I use the HTTP protocol because that's what they insist me to use it.
Yeah. So, but if the content is like, I mean, even when one byte it has changed, like mostly it will change, right? Like if there's a 1 year gap or something or a 10 days, there'll be, if there's a change, you have to download the whole content. There's no other way, right? You'll have to download the whole content, then you'll have to parse it to get the links present on that page.
Do we store the content or we just parse
Yeah,
it?
that's what my question is. Yeah, do we store the content all the time?
Right now you are storing, right? Because you eventually want you. So basically, the reason you're actually downloading the content is not only good to get the links. You're getting the document to actually create an indexer, to create a search engine.
Right. So, I mean, if we are downloading it, then in our design consideration, we also need to make sure that what are we going to support? Are we going to support media like sound files, images, videos, or just text?
Yeah. So that all things that so right now we are not worried about that. What we are storing, we just started what a web crawler is. So I'm just explaining what a crawler is, what problems it has. So maybe after 20 minutes, we'll go dig deep into all of the things. What we need to store, we have to make it extensible. We can make it fast and everything. Just cover all the basics so that everyone is on the same page, right?
So right now it is just like how we are going to crawl. Okay.
Yeah. So basically, you're just on a single machine, and what's the logic to do the crawl?
Okay.
Right? So we'll see what you get. Where are the, where are the bottlenecks? You are using single threads. What's the issue? We'll use multiple threads, multiple processes. Then we'll keep separating out the processes. We'll build machines that way. I mean, this way.
I got the similar questions. Start with a single thread to multiple thread, but I didn't need to download the content. That's why I was confused here.
Yeah, I mean, it depends. I mean, so in the interview, it's like you'll have. I mean, that all depends upon the question, right? So so you ask. So it's okay. Wait, did someone join?
Yeah, I think Arya, what company asked you that question?
So it was Lyft. It was Lyft.
No, that's for you, Ankur. But Arya, you said you got a similar.
That was the startup company. So.
Okay.
Yeah.
So.
Not from the FANG, not from this talk. No.
Okay. Yeah. So basically, you'll have to ask, right? I mean, so the question you'll have to ask to the interview is like, does the content change frequently? Is it not changing? Because for Google, if you're doing a Wikipedia crawler or a web crawler for the whole web, the content will keep changing. But if you're only making it for, let's say I'm working for a small company or a small startup who's supporting only blog websites, their content is not going to change, right? So this doesn't matter. It doesn't make sense to visit the same page again, or like keep crawling it again and again. So I think that depends upon the question you ask to the interview. That is what getting the functional requirements is all about. So this here we are talking about a Wikipedia in which the content keeps changing. Okay. So Okay, so I think now I actually want to get into the issues. So one of the issues that Devin already said was what was the issue? I think he said duplicate page. So that's the first thing. If you see the page again, what would you want to do with that? So how quickly can you? So basically, how quickly can you figure out if the page is duplicate, right? So let's say you have the page, you have downloaded, and let's say you get a similar. Now let's say that page is like big, like 500 KB or 1 MB, right? You download the same page. Now let's say the content. Let's not go with the content length because that might change based on other things. But
well, there's one naive approach and there's one optimized approach. The naive approach is just to store a database table with a list of all the URLs you visited, right? Which as that gets bigger, the lookup's going to get slower even with indexing, right? So that's one way of doing it. Another way to speed that up is because URLs tend to be unique. You could create a one-way hash from the URL, right? And put that into, well.
No, but the URL, same URL you're visiting again, but let's say the content has changed. The blog, I mean, let's say it was a PDF document, or let's say the content has changed. How will you know? How will you compare if the content has changed from the last time?
Content hash can be used.
Yeah.
Sorry, what?
You can hash the content of the URL.
Basically, you hash the content, right? You I think there is something called shingling, some concept. I don't know what that is. I just read it. So basically, you hash the content. You create some like a 64 length 64 length size of some hash. You store it in your database, and next time when you get the document, you create the hash and you compare it with the in the DB like quickly in like O of 1 or something, and then based on the hash you quickly figure out has the content changed or not, right? So this is just a top thing, but hashing the content also, like there are some many other considerations also, right? So basically, let's say I have Ankur and let's say I have Devin. They both might have the same hash, right? They both might have the same hash. So how will you make sure that Ankur?
No, yeah. Hey, Ankur. So I think if you do an MD5 hash, for example, it's always, unless the content is exactly the same.
Yeah, it's always unique.
The hash is always unique.
Or 256, SHA-256
Yeah,
hash.
so I think
yeah.
so. Basically, what I think what I mean. So basically, if you so basically, what I was trying to say is MD5 is something which is what is there, which is going on today. But MD5 is actually also, it uses multiple hashing functions. Like let's say you do a hashing, you call a hashing function Ankur, but you call 5 different hashing functions of the same content, and you do the same thing on Devin.
Okay.
That becomes MD5, I think, right?
I think I'm not exactly sure about the implementation of MD5, but that's been, we used it a while ago to compare images we get, to make sure that's the easiest way and the quickest way to compare 2 images or 2 data on any files. If you do MD5 hash, the data is same irrespective of the data type or the file type.
Yeah.
The hash is always unique for same value.
Yes. So basically, that's what. So basically, the point was that the documents are being duplicated, or let's say the page is duplicated. How quickly can you find if it's duplicate? You use some mechanism like MD5 hash to
or
figure out.
SHA-256.
Yeah. So I think these concepts will be good to know, like what these are. MD5, SHA-56. I mean,
Is it not
SHA-256.
expensive? Is
Sorry,
it not expensive to
So,
run the hashing
no,
on the whole content of the page?
it's not required in a system design for you to know I mean, we are not giving cryptography interview or something like that.
Wondering, like, I don't want the internet.
But no, but you need to know that. So let's say when you're so algorithms, like you'll be learning what hash maps are. So there is there is always hashing functions, right? So that is how you actually, that is why your hash maps are fast, like O of 1, because you're eventually using a hashing function, right? So if you use a hash map here, your interviewer will say, okay, what if the hash of Ankur and Devin are the same? So to solve that, you use multiple hashing functions. And the thing is, you're only reducing the probability of them being the same. So if initially the probability was 80% that the two hash times will be same, by using five hashing functions, it will only get down to 99%. It will never be 100%. So that is one of the things that will come from algorithms. That is something that you can actually say in the interview also, just based on the basics. Right. So this is itself. If you go to that course I shared, right? They have a small chapter on distributed hash map. So basically, they explain how do you. So basically, your Dropbox, right? Let's say you have Dropbox, right, or Google Drive, and let's say there are people who are like uploading the same image again, right? So Dropbox or Google Drive, they would want to figure out was the file already stored? If it is already stored, why should we store it again? Instead, why not we just provide a same link, like a sync link to that cat.png? So that is what they explain in the course also. So how they use it, and eventually they get into hashing, that consistent hashing and everything. So that itself is like a different topic, right? So let's drop this. So now, what second issue? Okay, so second issue also here is like, now let's say you are on apple.com, right? And basically you want to first scrap those URLs which are more important, right? You want to scrap google.com or crickinfo.com first rather than scrapping my website ankur.com, right? So basically a queue. So that's one of the problems. So basically you want to scrap the basically priority. Sorry, download pages based on a priority. Is this point clear? So instead of using a queue, our original queue, right? That queue is actually nothing. Will become a priority queue. We'll be using a priority queue instead of a queue.
Ankur, can I say something?
Yeah, go ahead.
So when you're designing any system, so first you have to come up with a requirement, right?
Yeah, we have not gone into the designing at all. We are still into the basics.
But right now you're saying priority queue and all that stuff is implementation, right?
No. So basically, I'm just saying that, basically initially you have a queue, right? Initially you start with your queue, which has like 3 URLs. And
queue is again implementation. That's what I'm saying.
Yeah. So when you start the crawler, you need some seed URL, right? So not just one, but you need some 3, 4, 10 URLs, which are very good.
No, I'm saying this way. So let's say you are designing WebCrawler, the customer comes to you, right? A customer comes to you. So what questions are you going to ask customer? What is the requirement, correct? Do you want to download text? Do you want to download media, right? What is the use case is there? Do you want to maintain the mirror sites of popular websites? Or do you want to search for copyright infringements? So or do you want to just test the valid syntax and structure of the web page? And then that, so
basically this comes into that requirements, right?
Right. So that is that. Then requirement is when you are giving a system design interview, the requirement would be like, one is text, whether you want to download text, media files, and whether you want to support only HTTP or FTP links or whatnot. Then another question that comes to, you have to ask your interviewer is like, how many web pages, like approximately ballpark figure, that you are going to parse, right? And then you have to come up with the storage capacity planning you have to do based on that. And
yeah, so basically at the end, when this basics are clear, we'll get into that as well. Like the page.
No, all I'm saying is like, if you're having a subsequent sessions, just come up with this skeletal structure and just stick to that.
But the thing is, we are not getting into system design for the interviews. This is, before this, we went into Flickr design just to understand the basics of how a system is made. I mean, when we did Flickr, we actually went into, Devani explained to all of us like what, so load balancer has sticky sessions. So he even explained what the sticky sessions are, what S3 is, how all the calls are going on. He didn't.
Okay, so just concepts we are doing, nothing like we are not
Yes,
doing
because
from,
there are, if you go to YouTube, you'll eventually, there are like lots of videos who will actually teach you how to like design only for the interviews. That
Okay.
is a lot. Right now, it's all about playing the basics, what exactly a web crawler is, like building upon the basics. So,
Okay, got it.
so I think you didn't know what the context of all.
No, I didn't know that. I read system design in the chat, so that's why I thought.
So no, it was, yeah, okay. So and the first, so this is the third session. The first session was basics of system design. That was like
Okay.
just basics, like what, we started from a single database, single server, and we kept what are the disadvantages of using just one machine, and one machine is having the database server and also the web server. Then
Okay.
because there was one guy, Jeff, so I think he's a college graduate, so he wanted to understand all of these things, and me also, and I wanted to explain, and there were more people who wanted to do that, so we thought we'll follow that approach.
Okay, got it.
Right?
Yeah.
Okay. So is this point clear to like like why would we use a priority queue? Right. So that is one of the things, right? Like instead of a queue, use a priority queue so that you always store the pages, the URL of the URLs which are like of very important pages, right? And I think another problem would be the scale. Basically, as VT said, so basically, so Wikipedia is like so huge, right? If the interview says there are like 5 billion, like 1 billion of pages, so that is your problem, and this is the problem that we'll be solving a bit later. So how will you design the whole system using your scale, right? And okay. So what are your other problems? Can anyone say? Devin?
Scope. Yeah, so scale how many pages, right? But scope and what's your endpoint? So the way we're talking about the system right now, it can do the entire web. So where do we draw a line in regards to okay, this is where we stop?
So I think it's for a Wikipedia, it's like a ongoing cycle, right? They keep scrolling. I don't think there's a end here. So so basically that's a problem. Like there's no end. Basically, you need to have a system which is like always working. A system which is always working.
So Ankur, a very silly question here. It's like about the priority queue. So how we decided that this URL is gonna go to the priority queue? Like, what are the is there some marker is gonna be there? Like, how we can decide?
So I think there is something called, if you know what is page rank.
Yes.
So basically, based on page rank, you figure out what is the importance of a page. Basically, page rank is nothing but number of. So basically, it
Number
says,
of pages.
if there are, if there are like Sachin Tendulkar, if there are more important people following that guy, he's a more important guy. And if there are 5 people following me, which are themselves not so important, so I'm not an important guy. So based on that, they figure out what the importance is.
see.
There's no other
Okay.
criteria. That is how actually Google started with using PageRank, and then eventually I think they kept changing all the algorithm and whatever. It's like what do you say, an IP, intellectual property or something, not shared, right? So yeah, I think there are So basically, and also you see that if you see this what we wrote here, right? Basically these points: get the URL, visit the page, and download the HTML. Now this point, right? Can someone see what problem this might create? The second point. 2.
Downloading the HTML, Ankur?
Yeah. So what problem? Like, so what is that problem like? Yeah. So basically downloading the HTML. So what are the problems here? And this is a single computer, and this is just a single thread system.
What
Anyone
if
else?
Yeah.
I think the bandwidth will be an issue since if you are doing on a single machine to download so many pages, and as well as we might get blocked. I think if we hit a particular URL so many times, but since we are using once, I think that's not be an issue. Yeah.
No, but basically your point is right. So basically you go to apple.com, you are actually not only visiting apple.com, but you're visiting apple.com/ipad/iphone/something many times, right?
Yep.
So basically, I mean, if you hit all those websites one after the other, that will be a problem. But if you use apple.com today, but tomorrow if you wait for, let's say, 10 minutes or 1 hour, they'll be fine, right?
Yep.
So basically, let's say there's an e-commerce website. It's a very small pop and mom shop. They are actually more worried. Let's say they just created their own system, like on AWS. They are more worried about they're more worried about fulfilling the orders, right? And that is why they created this system. Now, if there's a crawler who's like sending out many requests and hitting their server and overloading them, their server, they are going to their system is going to crash, right? I mean, their system would be actually doing the helping the crawler instead of fulfilling the orders of the customer. So that is the most, I mean, that is one of the problems. You don't want to.
In terms of memory being used up, Ankur?
Second.
Is it in terms of memory being used up of the system, of the single system?
I mean, yeah, that's also a problem, because eventually you are getting the HTML that can be huge, right? And if it's just one system, so basically the point that's a valid point. And the point I actually wanted to say was there are two issues here. Okay, first is, I mean in terms of first is so URL, you are given the URL, right? Let's say it is ankurkothari.com. Okay, now you hit ankurkothari.com on your web page. I mean, or you call it using some HTTP post or HTTP get. What is going to happen? What is the next step? So what happens to ankurkothari.com? So it goes to the. I mean, what is the next step?
Make the GET request. And
To
then
whom?
ankurkothari.com.
So who will know? How will you figure out where does ankurkothari.com live?
Oh, it does a DNS lookup.
Exactly. So basically, this DNS lookup for ankurkothari.com, which is like has never been visited by the current computer, is going to take a lot of time. And let's say I'm sitting here, and someone from and the crawler is actually in India, and my server is here, so it's going to take a lot of time for their system to figure out what is the IP address. I mean, what is the IP address associated with ankurkothari.com? So that's one of the issues. Is it clear? So basically, this is called DNS resolving. This is for any web crawler. This is one of the most important, or one of the biggest, things that will actually slow down the system. So because if you have like a 1 million or 1 billion URLs, imagine doing DNS resolving for all those URLs, and those URLs not. I mean, some of them not. I mean, most of them are not going to be so important that they're going to be in the DNS cache, right? DNS server cache or cache. So eventually there'll be a lookup. So that will make the whole system very slow. Is it understood? Like clear?
Yep.
Okay. Now that's one point. Now another point. It's a single thread. What issue can you get? Namita?
What's the question?
So you have, you have a single thread process, which is actually trying to download the web page of from some server. It's a single thread only. So what issue can you get here? I mean, it's pretty obvious. I mean, basically, your thread is actually going to wait for the URL to come back, and till that URL, till the content has come back, it's going to wait, right? It's going to hang till the content is back. So other requests are going to halt or pause for some time, right? So imagine you have DNS resolving, and then you have to download the content. So these two itself is bad when you're using a single thread, right? So thread actually waits for the content. So basically that is how, I mean, so how you do actually, that is why the thing is you use multiple threads. So as soon as one thread sends a request, it goes into sleep. And second, there's a single second thread is actually wakes up the first thread as soon as there's a response back. And other threads, they keep doing their own looking up or downloading the pages. Is that clear? Okay, is it clear, Sue?
Can you start from that part? Like how many threads are we spawning to begin with?
I mean, only right now it was only one thread.
So we start with one thread, which
Yes.
does what? It does a DNS. So you
Look
said
up.
there look up, and there are two threads, the one that sleeps and the other one that waits for the response.
No, right now there's only one thread. There's one thread who actually does the DNS resolving, who waits for the IP to come back and then calls the system or the server. And then after that, it calls the server, and then it calls the downloads the page. The whole system is now hanged till the first thread completes its own work. So the whole system is like blocked now. So now you might have like 10 threads. They all are doing their own work. They all are waiting, but while one first thread is waiting, the second thread is continuing its own work. Like it is also doing the DNS resolving and whatever it wants. And
one thread will do this DNS resolving and put them somewhere so that they will be readily available for the thread which is trying to download from the URL.
yes,
It'll
that is
update
all.
the cache basically.
Yeah, so that is also like a possible solution. You have different threads responsible for different things. You have one thread, so basically like a queue, like a worker who's actually getting all the DNS entries, putting into a queue, and there's a different thread who's actually reading that and getting all the results and doing another thing, and there's a different thread who's actually waiting on something else on the first one.
I guess the first thread, instead of, I think we need not even download. Once if we make one thread visit the sites, it will automatically get the IP address into the closest DNS server. So by just visiting, it will be available for the downloading thread to quickly look up from the closest DNS server.
No, that I'm not telling about that. The first one did DNS lookup. The second one got the IP address. Let's say it's 1.1.1. Using that IP, now it is going to fetch the HTML, and that server is, whose server is it? It might be Google server, it might be my server. My server could have like 2 GB of RAM, and Google's is like huge, right? And I might take a lot of time to give back the result. Like I might take 10 minutes because my server is actually busy servicing other orders. So you might get the result in like 10 seconds or 5 seconds. Till that time, your whole system is like, that thread is waiting, right, for the result to come back. So the thing is, you're waiting on an external system, and that is actually going to blow up. I mean, that is going to actually be like a bottleneck or something.
Got it.
Right. So while you send a request to a particular system, that thread now starts a different process. It goes into sleep. There's a different thread who starts a different process. It also does the lookup for the HTML, and one thread actually wakes up the first one as soon as the response is received back. So that's all coding, right? So that is what I mean by having a single thread, you get problems, and that is why then you start having, okay, well, I'll have a lot of threads, right? But when you have only a single process and a lot of threads, you're going to be having like context switches, and then you figure out, okay, I'll have more processes. Is this clear? Like, VT, do you want to add something? Am I not making sense? Am I speaking something bad, like which is wrong? Please keep adding, because even I have never designed anything like that before. Devain?
Look good to me so far.
Good. Sue? Namita? Arya?
Yeah.
And everyone, SKC?
Look good.
Yeah. Thanks everyone for joining today. Okay. So, I mean, these number of problems are like enough. Are there any other problems do you see? Like we already covered what if the page is duplicate? What if the URL is duplicate? We've seen DNS resolving. We have seen that the server, okay. So, okay. Now there was one more thing, right? Okay, so when we talked about external servers, right? There's another thing which I already talked about. So let's say you have apple.com, or let's say you have stackoverflow.com, or let's say there's an API URL given to you that you can use. There is always rate limiting, right? I mean, if you keep now, most of the websites, most of the servers, what they want is, if there's a crawler who is hitting us, they shouldn't be hitting us one after the other, like immediately, like, okay, first request, second request, third request. Instead, what they want is to have some gap between those requests. That is what the external servers actually would love to have. So that is actually, if you look for a literature on crawler, that would be called actually politeness. So politeness in the meaning, politeness meaning you call apple.com now, you wait for some time, let's say 10 seconds, then you call the other, then you call apple.com/iPad. Then you wait for 10 seconds, then you call apple.com/iPhone. I mean, just to be polite and not to hit the server continuously, right? So that is one of the features that you actually implement in your crawler. Is that also understood? Any doubts on this?
No.
Okay. So, David, do you know what is it? Exponential backoff means?
Yeah, which means one simple example, just to use the doubling, is let's say the first time you make a request, right? You you wait a minute, right, before you make the next one, okay? And then if you've already hit that page, you double the amount of time you wait. So next time you wait 2 minutes, then you wait 4 minutes, 8 minutes, 16 minutes, so on and so forth. So exponentially mean, okay, so it's actually 1, 2, 4, 16, 30, 16, and then 256. Okay,
128, 256. So basically, but that is what exponential backoff is. But usually, if you see, these crawlers, right, they have a limit as to how much they want to wait. Like they'll wait for one second. If there's no response from the server, they'll wait. Then they'll wait for 2 more seconds. Then 4, 16, 32. Eventually, okay. If after last request, it has been 32 seconds, they have not said anything, that means they assume the server is dead. They put the URL back into the queue at the end. Okay, we'll do that later on, right? And they'll not try it again. So that is what crawlers usually do. So this is nothing but exponential backoff. Is this clear? This is a very important concept. Like when I did my, I think my phone interview with Lyft, I mean, it was all, that guy actually explained what exponential backoff was.
So it has nothing to do with politeness. It is just about if the
No, I
server
mean, to implement politeness, this is what you do. I mean, you wait for some time. You don't hit immediately. Like you don't send all the requests at the same time, like one after the other. You wait for some time. So here you're waiting for like 1 second, 2 seconds, 4 seconds, not sending after a millisecond, then a millisecond, then 1 more millisecond. You're not constantly bombarding. So it is related to like politeness also.
Okay, it is related, but because we discussed that if the server did not give the response back, then we thought we will wait. So that's where I got confused.
No, yeah. So I mean, in the same thing, you're actually doing the both of the thing. You're also being polite. Wait, no. Yeah, I think for politeness, you wait for some time before sending out the second request. I think you're right. Before you send out the second request, you wait for some time. But here it's actually you send a request in 1 second. I mean, you wait for 1 second. If the response is not back, then you wait for 2 seconds. You send the request. If there's no response, then you wait for 4 more seconds. Then you send. So that is that now. So as you said, that's actually different concept. So first was politeness, to make sure there's always 5 seconds in between the request. Second is what happens if there's no response.
Got it.
Yeah. So exponential backoff is mostly used in cases of errors or when you do not get a response. So these are retrials. So
yes. So that was for retrial. This was, yeah. And politeness is waiting for.
So politeness, Ankur, like it applies to all Like basically from a server, all the child pages have to follow this decent amount of gap between visiting. How do we combine page ranking with politeness and make sure that there is the sufficient gap?
I don't know how page rank works. I mean, it's like it's a very complicated. That's a different concept now.
Okay.
I mean, crawling. So basically, I think when you go into the interview, right? I mean, I think
page ranking is a completely different.
Not page ranking. I
topic.
mean, in the priority queue, there is a rank, right? So based on the rank, we are getting them.
Yeah, but don't worry about how they get that rank. Assume that it's already
No,
there.
I'm
Because
not
if you
worrying
dig into
about
page
no,
rank,
she's asking something else. She's asking something else.
oh, okay.
So what I'm saying is, from the queue, based on some rank that each page is getting, we are getting it one by one. Like how do we know if the previous one is from the same domain and
Basically, what you do is what the servers are doing, they actually get the host. Apple.com is a host in itself, right?
right.
So let's say apple.com will be actually hashed and put into the database, right? And let's say you get apple.com/iPad. So it's very simple to get the host from a domain name, right?
Yeah,
So
yeah.
get apple.com, it checks, is it is the host name the same? And it also checks like what was the last time this website was actually visited using the
Okay.
hash string. So in OAuth1, it can quickly find that out, and then it
Got
has some internal implementation, I think back of queue, front of queue or something to implement this thing. This is itself like there's a paper on this, how they do this pressure, back pressure, front pressure and everything.
Yeah, what I mean is like say we are able to derive that information, but we don't want to wait, right? In the meantime, there can be another page waiting which has like a lesser rank, which can be processed without worrying about politeness. How do we combine these both and implement is what I'm thinking.
Well, we don't need to worry about that if we're talking about system design. That's more coding.
Got it.
So wait. So basically, you're asking is you're waiting for something, but basically you have a lot of systems, right? I mean, you have a lot of. What you're saying is actually a production system, and that production system already has it doesn't have just one crawler.
No,
There are
not
going to be
one
multiple
crawler.
crawlers.
Right. But this crawler, like, yeah, when there are multiple crawlers, also this same problem will arise, right? So we saw
No, it's gonna defer it and then process the next one.
it's gonna differ. Okay.
As to
Because-
how we want to defer and how we want to handle it, I think
So
that's a
page rank, right? If you see page rank of every link
No,
is going to be between 0 and
Encore. It's not the page rank. I think what she's trying to get at is, okay, let's say we just recently visited apple.com, right?
Mhm.
And my next URL is another apple.com URL, okay?
Mhm.
So because of politeness, we're gonna back off and not make that request, right?
To apple.com.
Right.
Right.
But in the interim, because we're waiting on apple.com, we can process the next item in the queue.
Which should not be apple.com.
But wait,
domain.
we are not even processing, right? So we are not waiting for anything. Aren't we not
But for
waiting?
the politeness, we are waiting, right? Before making the next.
Yeah. So basically, right? So basically, let's say you remove apple.com, you check, let's say this length is 100,000, right? You check if apple.com is when was the last time you checked apple.com? If it is like less, you don't do anything, you put it back into your queue. Right? You're not checking anything. You get the URL, you check what was the last time it was you visit
Okay.
apple.com, you don't do anything. I mean, you don't even call anything. You don't do any politeness.
Okay, that I think
You
that's
put it, you put it back into the queue. I mean, basically, you put it back into the queue using some concept. So that's actually an algorithm question. So I mean, I put some 5 to 6 questions, right, for Sunday weekend. There's a question called task scheduler. That concept, that implementation is exactly similar to this. How do you maintain a queue so that you have to wait for some particular period before you start it again? So it's also there on LeetCode, but the question I'll be giving is a bit different, but it's the same thing. So and that is done using queues, right? So let's say you have a queue which is of 3 milliseconds of length 3, and if the exponent if the politeness is let's say 3 seconds, If the element is there in the queue, that means it was seen in the last 3 seconds. And if let's say google.com is not there in the queue, that means I can safely implement it. And as soon as I visit it, I put it in the queue. Put in the queue means I just saw it recently. And as I'm removing elements from the front, my queue is getting shorter. So, I mean, if you come on Sunday, we'll do that question. It'll make more sense. Fine. Did it make sense too?
Yeah.
Okay. So, is there any other? So we talked about exponential backoff. We talked about threads. We talked about politeness. What else? Is there any other issue you guys see? Basically, we'll be coming into storage of files. That is obviously you're storing it somewhere. So basically, now I'll draw this basic system of what a WebCrawler looks like. Okay. This is there's a paper called Merater or something. They were the first guys who did some research on crawler, and Google also uses that. I think it's very heavily referenced. So this system is actually taken from there, right? And actually, if you see the Harsh's video also, it's also the same thing. Okay. So basically, initially, right? I mean, this is a very small iPad, right? So basically, I'll try to keep it. So initially, you had seed URL, right? And let's say you have a HTTP downloader. That is what you said, right? We have an HTTP downloader. Call it anything. We'll call it HTTP downloader. And this downloader is actually calling the DNS resolver. So HTTP downloader actually takes from the seed URL, calls the DNS resolver, right? Gets the IP, downloads it, gives it to the parser. Is that right? Then this goes to after the parser. There'll be a different system which actually checks for was the content seen before. That is what we talked, right? To check if it is a duplicate. That is what David also suggested. And after the content was seen, David also suggested what if it is a CSS? It's a URL to a CSS file or a JavaScript file. So there'll be a different. So basically, after you download the page, you parse it, you're going through some checks, right? So there'll be one which is actually doing URL filtering, right? And after URL filtering, what you do is you actually call another thing to see if has the URL been seen before, and if it is not, wait, it's all isn't there also a so actually sorry, there's also a URL frontier. So this is your queue actually. This actually implements the queue, and URL see if it's not seen, it sends it back to this URL frontier, and this HTTP downloader then gets the URLs from the URL frontier. This is your simple, very simple web crawler. So this is your downloader. So basically, I think this is I think if you see the Harsh's video also, there's a downloader, there's a parser, and then it goes to some checks, content seen, URL filtering, URL seen, and then after this URL seen, its purpose is to put only the valid ones into the URL frontier. If it is worried about that you have to check the website again because it might have changed, it puts it back into the URL frontier. It's a concept. It's some logic which is only handled by URLC. Is this making sense? And this parser, right? This actually there's also a storage of files. This is actually shared by the HTTP and the parser. So basically, HTTP downloader, right? It gets the files, puts them into this database. Parser gets them from there and then does the parsing. And this URL seen, there'll be a different database at the bottom, which is only storing URLs, like URLs, so URL storage. Is this clear?
Can you repeat? What is the leftmost?
Oh, wait, what did I remove? Leftmost. This is seed URL.
Mhm.
I mean, when initially you start from some URLs, right? Some 3, 4. Right. So that is your seed URLs. Like, and these seed URL, I mean, you basically want to cover, it can be anything. Let's say one URL can be related to cricket, like based on topics. So one is related to cricket, one is related to football, one is related to geography, another is related to something else, like seed URL. Like URLs that will help you crawl a lot. Right. And eventually, this is what the URL frontier looks like. This is nothing but the queue. It's called URL frontier in the paper, and it's nothing but a queue which is actually storing all the URLs, which the next the crawler or the HTTP downloader needs to parse now or download from. Any doubts on this one? Sue?
It's clear, Ankur.
Everyone, I think Anil, you are the first, you guys came first, right? Is this?
Yeah, Uncle, following you. Thank you.
Ask, like, guys, ask any doubts. I think Deven is here. VT is here. I think is VT still here? Yeah, like ask any doubts because these are guys are here to like clear your doubts. Harsh won't. He'll only come on Tuesday and you won't be able to ask it out. So remember this. Mostly in your onsite, you're going to get Wikipedia crawler. And next,
Ankur, can you just explain the steps one more time?
Of this?
Yeah, seed URL and the.
So basically, your system, right? It starts with seed URLs. Let's say you have a downloader, which is your starting machine, right? I mean, and you start the crawler. So basically, your HTTP downloader goes into the seed URLs and gets them. It might be stored in the HTTP downloader itself or somewhere else, but it gets those URLs, right? It goes to the DNS resolver, as we discussed, to figure out what the IP address is, and this is one of the most important. I mean, it is one of the most important time-consuming process in a crawler, going to the DNS resolver and getting it, right? I mean, first time, every URL is going to be visited for the first time, even apple.com, google.com, or anything. If it's not there in the DNS system, or let's say it's not there in the, so first it looks into my computer, like is it stored in my computer, that mapping? If not, it goes to my, I think, local ISP. Then it keeps going back, right? And until it finds out where apple.com/iPad iPhone is, right? So that is going to take some time. And this can take like 1 second, 2 seconds, whatever, I don't know. But that is an important step. And so after it has downloaded, right, it puts into the storage of files or a database, right? Because your parser, next step is parsing. Parsing gets those files to parse them, right? And also you want to store them like for, let's say, 5 years or 10 years, or maybe for checking duplicates. You still want them, or maybe for indexing. Your indexer is also going to use those files, right? And after the parser has parsed those files, it is there's going to be some filtering, some steps on that, right? So for example, as Deven suggested before, the content could be duplicate, right? And if it's duplicate, you don't want to parse it again, so you can just stop it in the content chain. Okay, now the content is not same, it checks for URL filters. It's only looking for HTTP URLs which will make sense in the future, like blog post, which will go. It's not looking for PNGs or JPGs or JavaScript files. So that is what URL filtering does. And then you have URL scenes. There's a different process. Process which actually checks, should I actually put the URL back into the URL frontier or not, right? And it might have all those whatever page rank and anything going on internally. We are not worried about that. But right now it's all basic. So this is the base. Is it clear? And URL scene is also putting the URLs in a storage called URL storage.
Yes, Ankur, understood. Thank you.
This is going to be like if you go to educator.io, this is what you're going to see. Everything will have HTTP downloader and a parser, and then you'll have some steps for doing some steps that will actually do some filtering on the content and the URL. And there'll be a URL frontier as well. Okay. Okay. Now, should I go to the next? Anyone has any doubt? Devin, is it making sense?
Yeah.
This is the first time I'm taking. Devin, this will be a question to you as well later, because even I don't know how to handle that. Like, how do you actually design that? So basically, you guys see here, right? So this is, let's say for crawling, right? Let's say there's a URL which is, let's say this crawler is right now in USA, right? And it gets a URL which is India based. So it has to do that whole, there'll be latency problem, right? So basically what usually happens is there'll be a crawler devoted only for US geography. There'll be one crawler who's running in India and they are working together, right? So basically, is the problem understood? So basically what we are doing is we are putting crawlers in their own geographic locations so that parsing the URLs, so let's say anything .in, right? Most probably it will be in India. So you want to have a crawler which is actually just working on .ins, or maybe ndtv.in or timesofIndia.in, right? So you want to have, so let's say your parser gets a URL, Wikipedia, like a page. It sees there's a page, it sees there's a host called India.in or cricinfo.in. Okay, this is not my problem. I'll give this URL to a different crawler now, which is in India. So that will work now. That will do its own parsing now. And if the India crawler finds out there's something which is .com, it will send it to this crawler. So we'll have crawlers running in different regions. So I think that is when I think Devin will help. Or do you want to do it right now itself, Devin?
We can go through it right now. Essentially, when you initially do the DNS lookup, you can figure out where you can do geolocation, right? So one naive way of doing it is you have different queues for different regions. So you can have one queue for let's say EMEA, right? Another queue for USA. So depending on your DNS lookup and your geolocation, you figure out which queue to put it on, right? And then depending on the queue, you're going to have different machines, or let's say a cluster in each area, and that's going to handle the processing.
Yeah, that's awesome, Devin. So basically, so what did you guys understand what he said? So based on the geographical location, your this crawler or the parser is actually going to get the URL and it's going to contact the other crawler and going to put the URL into its URL frontier, into the URL frontier. Is that understood? Because that is how every downloader starts from the URL frontier, and that's a logic that actually within each crawler inbuilt. Like you write that logic. Is that clear, guys?
Anyone have any questions around it, or did it make sense?
Yeah, makes sense.
It's the first step on downloading the URLs, right? And
Oh, you're not even downloading it. When you initially get a URL, you can do a DNS lookup.
So basically, you just parse. Basically, you're here right now. You just parse the page.
You don't know. You're not going to even parse the page. You're just going to.
No. What I'm saying is, at the first, when you parse the page, you got some URLs which are related to India.
Yeah. Okay.
Right, and then this parser is actually going to put those URLs into the URL frontier of the Indian crawler, the crawler which is in the different geographical location. Clear? What was that the question? Clear? Say yes, no.
Yeah. Okay.
I mean, if it's not clear, tell me. I mean, this might not be the good idea. Maybe you guys have some other idea how to implement
It's a naive way of doing it, but it's just for the purposes of this problem, at least in a basic system design, it works.
Yes, because I mean, so that is one of the other problems, right? So I mean, how do you keep the geographical look? I mean, how do you keep the latency down, right? And one more thing would be, so when we came into this concept, right? If we are splitting the crawlers based on geographical locations, we can also split the crawlers based on host names. So we have a single crawler just handling apple.com. We have one crawler just doing google.com, or we have one crawler who's only handling sports, one crawler handling only biology, one geography, something like that. So since since we'll be having a lot of commodity machines, no one is stopping you from implementing as many crawlers as possible, making it efficient. So basically, for that also, you'll have the same system here as well. Basically, you'll have a system in between parser and the content chain. Basically, that system is also making sure, okay, it gets the particular host name, it gives it to the crawler who's responsible for that host name. So there is another option, right, to handle all the scale and everything.
Ankur, can you repeat what you said last? I kind of missed it.
So so basically here this is understood, right? Your crawlers are based, you have different crawlers which are based on different geographical locations, right?
Yes.
At the same time, you can have crawlers. Wait, let me think how to explain that.
Ankur, I have a question based on the geographical location where we are feeding this into URL frontiers of that geographical location. For popular sites like apple.com or google.com, the request can get redirected to like any server. They will have servers across the world. How do we identify that these should be belonging to
No, but your Google Wikipedia crawler, right? There are going to be 95% of your pages or 99% of the pages are not going to be apple.com or popular websites. Popular websites are like only 1,000, right? After that, it's all your small websites, right? You're not worrying about the top 1%. You're worrying about the bottom 99%.
So, but in case of those popular websites, how do we know which it can be? Any...
I'll send you the link of the paper. You go into deep and you.
So I think to answer that question, I think whenever we first make the DNS request, the popular website, for example, apple.com, will give the closest one from where we, for example, if you are making that request from crawler one, it's going to give us resolve back to a USA IP so that the request can process from the same crawler one.
Yeah, that makes sense. Right.
Yeah. So for example, somebody is trying to access from India, it would come back. Is it not the nearest DNS location it would go, like, kind of geolocation kind of thing, and resolve from there?
Basically, the request would go to a load balancer, right?
Load balancer
would look at the incoming address, right? And say, okay, what is the machine closest to this address?
Exactly. Okay, got it. Yeah, that's what I was just trying to clear up the concept. Yeah, thank you.
But is it is this the same thing that we have different crawlers for different geography, or did the answer change? I couldn't follow what is going on.
The question was, how do you determine what's the closest machine?
Oh, okay, yeah, okay. Was that your question also, Sue?
Right.
No, your question was, I think, different. Your question was, I think, apple.com is present all over the world.
Yeah, but it will anyways get resolved to the closest one. So
right. So it would come back closest to the crawler machine, right? But in the case of a site that's rarely used, like ankurkatari.com, which may be based in India, and it's not replicated, okay, it has to route to India, right?
Yeah, but there are systems, right, who only have two systems, one in India, one in US, right? And that's all. It's not apple.com, but let's say GoDaddy, we have only two geographical locations. One is US, one is, let's say, India, Asia. In that case, what in that? I think in that case, if based on the DNS resolving on where exactly, if the website is in India, I think I'll be storing it there only, right?
Running closer to India, it will go to India. Otherwise, running closer to US, it will go to US.
Yes. I think what you also said that whatever is, we are talking about server, right? We're not talking about database. Okay,
no, we're talking about server.
Yes.
Okay. Is this different from the content delivery network, like where it takes the nearest edge locations? It's completely different, right?
That's different.
But don't they also do the same thing, like based on the from where is the request coming in? They pick out.
Yeah,
take the
based on where the request is coming from, it's going to redirect to the closest CDN, right?
Mhm.
So I mean that's the like I think that's the concept you're trying to figure out where the server is, the closest server is, and you give that. Because if you send apple.com is US website, I think apple.in is Indian website. Apple.in, I mean the apple.com version for India. And I think if someone starts from apple.in, there's going to be a lot of apple.in / iPad, iPhone, blogs, careers, and everything, right? So for all that, they'll have to go from here till Indian server. So I think instead just send apple.in to the Indian crawler and let them do everything, right? Even though they have their own, yeah, that's what, right? Did I say it correctly?
Yeah.
Okay, awesome. Okay.
Even the CDN, right? What happens is, I think, if at all the region is a little far away, it will go to the nearest edge location, pull the content, and store it to the I think, yeah, to the cache. And any further requests will go from that nearest edge location, whatever the regions are. You know, that's how the data centers are set up.
You mean edge location goes to the server, that S3 server?
No, pull the data and cache it.
Yes, yes.
To the
Yeah, I think that is what Deven explained in the last when we did Flickr architecture. Yes. So yeah, that concept actually makes sense here. So I think what else do we do in crawler now? Is this all about crawler? Is there any other thing that we missed? I'm sure there's I mean, this is the most basic concepts about the crawler. This is what a crawler does actually. And now if you've gone through, I mean, if a lot of things make sense to me also in a crawler, now I know what a crawler is because I read it. And if I go and do some system design, I read upon it, it'll make more sense. So Devan, is there any other thing that we missed? Each crawler needs to know.
No, we got the basics for a single machine, right? Now we need to talk about scaling.
Wait, let me, I had my notes. Let me see if I missed anything.
Okay.
Okay, so basically, okay, so this was geographical location, right? I think someone was asking about what I said about host, right? So basically, this is the thing. So when you talk about host, right? Host is nothing but the server, related to the server, right? So we also talked about what is it? Politeness, right?
Yep.
So so how do you do that? So how do you wait? So let's say you have a server who is handling only host. So I think just to handle politeness, right? So one of the things that I also read was there are servers who are dedicated to particular host. Let's say apple.com only. That's it. And they not only apple.com. And they know that how like they will manage everything related to politeness to exponential backoff. So basically what you're doing is you're also making your crawlers like divided based on the host names. I think I'm not sure what it is. I mean, just
basically,
read up.
You have a crawler dedicated to a specific host, right? And
yes,
that crawler manages how polite it is to that host. Right?
Yes. No, but what I thought is, let's say you have a crawler who's only responsible for apple.com. But what if that crawler actually visited apple.com recently and it gets another URL which is related to apple.com/iPad? It is not going to hit that,
it's
right?
going to go off. It's not going to hit that because it's off the base host name.
Yeah, it is not going to hit that. But isn't that means that server is going to be idle now?
Right.
So that means now the crawler is being wasted, right? So that is what I mean. I did read that crawlers are divided into hosts also, but I didn't go into details.
Right. But what you could do is assign multiple hosts to a crawler, right?
Yes.
What is it typical?
So that way, you're. Yes.
Yeah, what is a typical polite time? Like when these web crawlers, like how much latencies are we talking about?
Politeness depends on one, isn't it robot.txt or robot? I don't recall.
Yeah, there is robots.txt.
Is completely like it does not want, like if something has in robots.txt, it should not be crawled at all. It's not just about politeness about waiting and rate limiting.
No, I mean, if you're sending requests, I think 1 per 10 seconds, it's fine, right? Because that's fine. I mean, 10 seconds is like every server will be happy with that. But you should be, huh?
Yeah, is that the standard politeness time? Is it?
Yeah, in robot.txt, you can, there's a
robots that
property called crawl delay, right?
I see.
Which basically says, hey, you have to wait how many milliseconds before crawling each page.
Okay, yeah, I think before you hit any server, you first ask the server, do you have a robots.txt? I think that is what you do, right?
Right.
Yeah, I think that is worth reading also.
From what I know, robots.txt contains only the links that the server does not want, the child pages that the server does not want to be crawled.
I think that only thing is, it's not very urgent, right? That you finish up all the hosts. Crawler doesn't care that you visit Apple and you have to finish them at the same time. Even if you start Apple today and you finish Apple tomorrow, it's still going to be the same thing for the crawler, because eventually it's a process that is continuous, right? It's always running, right? So I think if you send one request now, send request again, let's say after 10 seconds, but in that 10 seconds, you're actually calling Times of India. But that's fine for the crawler, right? And then 10 seconds done, then you call apple.com. I think that's being polite. Instead of sending all the requests, let's say in 1 second itself, you're sending 100 requests to the server. That's going to be very bad. So I don't know what that standard politeness is. I think that's something worth to be reading. What that politeness is. If you read the paper on this crawler, there's a lot of stuff you can go into that. Like what is the standard thing everyone uses? There's a lot of things you can go into it. And also there's one more thing that I want to point out is the URL frontier, right? We didn't talk about this. Remember I told what this is? So what is this, Sue? What is this? URL frontier. I showed in the diagram. What was this? What was its purpose?
Yes, contains the list of the seeded URL.
Yeah, so how? The question is how? How will you do that? How is there? How is the queue? How is that list of URLs implemented in this machine or server or whatever process?
You mean the data structure?
The JSON snippet. That way you can contain the URL and some other metadata.
So either you can use a database, right? Either you use a database.
I see.
Right. But using everything for the database, it's going to be like very bad. It's going to be very slow. Every time you touch the database, it's going to be slow. Right? Because it's touching the disk and it's going to be super slow. There's going to be random IS. Another thing is put all the URLs into your queue. Into the memory of the queue. That is going to be very fast, right?
Yeah.
Right?
So
because
here can be like a Redis cluster.
Writing the initial seed will start with the cache and the memory, and then writing can be to the database depending on like the volume of the URLs, and we can fetch from time to time on a specific set.
Basically basically what they do is they use a hybrid solution. They make sure that there are URLs in the memory also, and and you don't want to keep the memory full, and you keep rest of the stuff in the database. And your downloader, right, is always going to the memory. And internally, if the queue is getting empty, the server will take care of getting the stuff from the database and putting it into the queue. Now downloader, someone else doesn't have to go into the database and look for the URLs. So there'll be a hybrid solution for the URL frontier.
So Ankur, when you talk about the putting in a memory, means we are talking about your memcached or something like that?
Yeah, memcache or Redis.
In memory, basically the idea is something in memory. So because of which is making it fast. For everything you shouldn't be using. So for a memcache or Redis, so memcache and Redis, memcache was built for Facebook's purpose, and Redis also similar for a very big scale. And there might be other use cases like other other implementation, like I think Amazon Elastic Cache, which is much simpler than memcache, which you can use here instead.
I see.
Elastic Cache uses either Redis or memcache underneath the hood.
Oh, okay.
So
They-
Elastic Cache has the underneath of the implementation of Redis or Memcached.
But I think you can decide how much of Memcache. I think how much of you can configure your Elastic Cache. I mean, basically, yes.
you
Some
can
some
show how
cache.
much memory to allocate to each cluster, right?
Yes.
I
Like
see.
if you want 2 GB or like whatever. But essentially you're using Redis or Memcached, right?
Mhm.
But I mean, in the interview also, right? I mean, the best thing is not to come up with technologies, but to just say it's an in memory, like you have machines and you're storing
Yeah, I see.
everything in the in memory. If you go into the basics, then it's sometimes like a red flag. Like, why is he talking about?
I see.
Yeah.
I got
But
it. What
yeah-
you mean? But I have a question. So it's when you say also you put it the content also in a memory too. But these contents are a lot. It's like some only for the popular website we are putting those
Which
content.
content?
Like no, you mentioned it right now that we put
Storage
it we are gonna put the content also. Yeah,
No
something in the
content. This
memory.
is only for the URLs. This is URL frontier. This is only for the URLs.
So sorry. So you say, can you repeat it? What you said? Like
Wait.
only for the.
So right now I was talking about URL frontier. URL frontier is a place which has all the URLs only for
Yeah.
the HTTP download to pick up from. And you were asking about the content.
I think you mentioned in between, so I thought I got confused. Oh, okay, never mind.
No, no, this is not about content. Content here means URLs, and these URLs you're putting here
Okay.
in the in memory. The URLs.
Okay.
Content being the URL.
Okay. Got
Yes.
it.
And if you what you might have like answer was memory. I mean, content would if it's files, they only go into the database because.
Yeah, that's what I was wondering. Like how you then it's gonna be too much memory we have to provide it. So that's why I was a little confused about it. And that's why I clarify first question and try to clarify second one. But I guess I kind of missed the content.
No, but it's good that you asked for the clarification because yeah. Wait, I think Nima, are you in?
Yes.
Okay. Yeah, because.
Okay. Yeah, I think my internet was very weak and so I got kicked off and I didn't have the URL.
Okay. I never noticed that my Zoom URL is always the same.
Oh, yeah, I know. I
Always.
kind of went back and scrolled back the messages and just randomly.
I think
Yeah,
BT
I think it's the
pointed out
same.
that. Yes. Yeah,
Yeah.
that's good actually because I sometimes forget to put it in the other Slack channel. And is there anything else? So that this is all basic stuff for other most other implementation sites. How your queues are working, how your how the hosts are being decided, URLs are being filtered. Just read some a paper. Just go through it. You'll understand a lot about this if you want, right? And
which paper is this?
wait. Let me just Google it. Something like so this is WebCrawler. I don't know. I'll send the link back. But that.
Okay, that's fine. Yeah, yeah. Don't take.
But
yeah.
all these implementation, right, by all Microsoft, Apple, and whatever, they'll all have the same. Like they'll have the same this thing, seed URLs, DNS, this thing, and what else? Okay. Now, so you had gone through Harsh's video, right?
Yes,
Now it's your turn.
I don't remember anything I just said.
Okay. So basically, my question for the left on side is, and I hope after 2 years that contract is gone, question sharing thing. I don't know. So basically, what they wanted is design Wikipedia crawler and all the above concepts, whatever we did, and for those concepts that they never asked me to go into the deep thing. No one will ask those things actually. But if you are interested, go read the paper. They might be helpful in your day-to-day job. And they said you're given 10,000 or 1,000 commodity servers. right? And these commodity servers are like 2 GB RAM or 4 GB RAM, and let's say 100 GB or 128 GB disk. Like if you go to AWS, like basically the free Ubuntu machines. So basically you have to do this using, you have to design the whole wiki crawler using 1000 commodity machines. And in between, one of the questions was, now there are only two types of machines you are using, right? One is your parser. So one is your downloader. And one is your parser. And then you have all other systems also who are doing your URL filtering, design, filtering, content design and everything. Content, unique thing. So basically his question was, how do you make so these are the two machines which are going to be like the most active, right? The most active, and you have the URL frontier also. Now his question was, how do you make sure that if let's say there's a popular website and now there are a lot of URLs, or there's a very popular website, it has a big content, right? So this HTTP download is going to be now very active, and parser is going to be it's also going to be very active. But how do you make sure that there's a proper balance between that? So let's say you make it initially there are 500 over here. So how do you make sure that there is someone like a master machine? How would that master machine work with this downloader and parser, and how will it make sure that there's a proper who will actually make sure that the whole crawler is actually running smoothly? So that was his question. That is how this was different. And I think that this is where I actually went with a master machine. And if you have gone through Harsh's video on Google file system, he has a master machine, right? And there are commodity machines, right? And he has also a database which is actually seeing which is actually storing that which machine is doing what, and based on that it is converting one downloader into a parser, right? Because if there are 500 machines and it wants to convert one download into a parser, it can do that, or it can convert into 100 or 1000, 250 or 750, something like that. And that is what master machine will keep in. And your master machine is also a commodity machine, but I think in that he actually changed it. Let's say there's one master machine who's like big. So that was the question. And then in that interview, I actually used this Harsh's concept of GFS to implement the whole crawler using whatever I designed up. And based on the feedback, I think it went well actually. So Sue, what do you remember from Harsh's video on crawler?
Pretty much what is discussed today, Uncle.
Oh, really? Okay. You remember GFS? Anyone remembers GFS? How Harsh explained? Or basic Google file system? Huh?
I didn't watch the file distribution thing that you're talking about. I just watched the crawler, and they didn't discuss about GFS or anything.
Okay. So basically, in my on-site, right, I actually used both of them concepts like GFS, and because his idea was, how do you make sure that the parser and the downloader, they are in sync, or how do you use them together? So right. So that is when I went with the Google file system. There one master, one database, which is actually knowing who is doing what. And based on that, I kept changing how many machines of each I have. Right. And also, Devon, is that right? Would that be a right answer? A good enough
that
answer?
could work.
So I think at the the beginning of our call, and asked you something, right? So so all these crawlers, right? They are working together, but wouldn't there be a master machine who will be actually? Do we need a master? Or don't we need a master who are actually controlling all of them? And if there's a master, would there be a like now your master is like dead? So how would you even design have fault tolerance in that? Is it a valid question?
You need to have a slave. You need to have other machines that can be designated as masters, right?
Mm-hmm.
And if the master machine goes down, one of the slave picks up.
No. So my thing is,
Yeah, one suggestion I have is, so the master is pretty much like it doesn't need to be a bulked up server. It can just be a commodity machine. The only thing
Yes.
it
right.
does, it just manage the server, but I think the master machine itself doesn't store any data. It's always stored in a database which is always backed up.
Yes.
Database
That-
consists of how the nodes are managed, or what node is processing how many
Actually,
URLs.
that's a very valid point, because in my onset also I told that I need a bigger master, because I thought, okay, master means big, but then we
Yeah,
came
no.
to the point that a master is going to be very simple. All it does is what you just suggested, and it can be a commodity machine. And then I think it was, I mean, it's actually a very valid point actually.
Yeah, we did a similar project at my work. So what we did was, we have we have an app, and then we didn't have time to scale or refactor the app. So we implemented a similar architecture with using Docker containers. So we didn't refactor the app because there is a limitation on the app. So we just deployed the same app in various containers. A master is managing, and then so we increased the scalability there in that way, using Docker and without touching the app code base. So
Yes, but in all, I think all the papers that you see, I mean, on crawler, right? You will never see a master, I guess. I think master only came here because based on the condition that my interviewer gave, that you have only you have only commodity machines, and you have to make sure that they are evenly balanced, or the work is going smoothly. But I mean, we'll see. I mean, I'll read a paper and see if there's a master in any of those architecture.
No, there usually shouldn't be a master.
Yes. Yeah. Anyway, master. Yeah, because this, I think individually, if all the machines are, I mean, the crawlers are working together, I think they will work on their own, right? Otherwise, if you're managing all those, like so many crawler machines, like so many, because they are divided into host geographical locations, it'd be like so difficult for a single master to like even manage them.
Basically, you can have worker threads on each machine, right? And the thread job is to pick up stuff from its frontier, right? If there are no threads left on the machine, it's not going to pick up anything from the frontier, which means, okay, it's full, right? Then in a bigger situation, you would have some sort of orchestration platform like Kubernetes, for example, right? Where if you see, like, you can set conditions. If you see, hey, that a lot of machines have their thread taken up, right? Start spinning up more machines.
Now there is some property, right? Like in your YML file, you can have number of pods. I think I don't remember, but you can, like, if this goes below this, you can increase the number of pods or the number of nodes. And that's what you're saying, right? Yeah.
It's not number of nodes. If the load gets to be a certain point, you can tell it to start spinning up more machines. Otherwise, if you have more machines that are freed, then you start killing them.
And those machines, when they come up, they'll automatically go into the URL frontier and then start crawling whatever they want, or whatever their business is. Maybe
there are specific threads on the machine which handle, hey, go to the URL frontier and grab stuff.
I think then, if I remember in my interview, I think those 1,000 machines or 10,000, they were only supposed to be for one geographical locations. Then I think that master would actually help. I think maybe. Or maybe there wasn't a requirement master. Maybe I went with master machine. Maybe I shouldn't have one. But based on the look of the interviewer, I thought it really went well. And he actually himself told me, Ankur, this session went well. Then I told, okay, let me take the photo of the whole whiteboard. So yeah. So I think, is this all about, so are we done with Wiki, like crawler? Was this helpful? Any doubts? Deven is here, VT is here. Or VT has left?
VT left a while ago.
Okay. So yeah, so Deven is here and Sue is here. So if any doubts, do ask.
So I just want to clarify about the master thing, what you mentioned. This is what I read from the notes from the Hirsch, that whenever the master fails, it take over by the slave. And you should have like backup for the master, basically.
Right.
Is that how that, is it correct thought, or is it
No, but I
something?
think if you read the GFS paper, right, they don't have a backup for the master machine.
Oh, GF. I haven't read that part. Oh yeah, I
So
haven't
basically,
watched.
what he actually taught, he actually teaches is from the GFS paper. And if you read the GFS paper and also his question, his one of his answers was even the paper, there's no mention about using a backup. Or maybe it is because the paper forgot to mention it, or maybe they actually don't use it.
I see.
But I think yes, you're right. There should be for such a big system of GFS scale, there should be a backup, because if the master is gone, then gone, right?
Yeah, yeah. Or either somebody mentioned here that you can have every time you're backing up for the master in a database, so you can quickly recreate the replica, so something like that. But still you need something slave that
At least
otherwise
one slave.
Yeah.
I think, but if the, I mean, one of the question was, if the master was down and there was no slave, the system would still be working, right? Because master is not doing anything. It's all it's doing is just tracking
It's
who's
not
doing
going to
what.
allocate new machines.
Yeah, that's all.
Yeah, that's right.
Yes. I think that's why GFS paper didn't mention it. And also remember, the GFS paper, right? It's only for one particular use case. It's not used for all. So though their use case was the content never actually changed. I mean, rarely changed. So that
I see.
So that was so. I mean, what I actually learned from like that, don't just use GFS like for all the implementations where you have a lot of data and you want to do a file system. I think in the future, I think Devan also suggested we need to go into design file system, like scalable. So
Yeah, I
we'll do that as
haven't
well.
gone through with those videos yet. I mean, I just did some of them, but I haven't gone through that. So I guess that's a good idea now.
Yes, I think we go into the session, we discuss, we talk about all the doubts, all the things that we talked about. Then if we go to the read in the paper, I think that will make more sense. Yeah. The idea was this, like, not learn alone. So is this all about, so Sue, was this like, did you learn, like, understand anything?
Yes,
Anything out of this?
definitely. One problem I'm seeing with the system of having a priority queue and like going like keep visiting the changed pages is like all the newly added pages will never get to see the light of the crawler, because priority queue will never get them to the front. And
Well, we're not. Don't worry about the ranking, because it's an unfair
that's
system,
a different, whole different problem.
This is a naive system.
Yeah. Just thinking out loud based on what we have discussed.
And then basically, so let's say you're given this question, right? And let's say if you talk about, you ask indexer, the interview might say, okay, let's not go into design crawler. Let's
Don't even bring it up, because he might just start wanting to dig into that, and that's not what the scope of this question is.
And indexing itself is a huge problem. Like,
what I'm thinking is, if I mention priority queue, I will not mention frequently updated pages. So that will solve that.
Yeah. So I talked to Abbas yesterday. So who got like offer from Firm and Indate and whatever, like he got staff. So he told me, so whenever I get a chance, do share it with others. So what he said is system design, right? System design, it's very easy. So just go to interviewing.io, give 6. If you're clear with all the basics, go to interviewing.io, give 6 mock interviews. And there's a particular format. If you follow, I mean, not a strict format, but keep that bandwidth. But there's a particular way to handle all interviews. So as we just now discussed, that don't ever talk about something which you're not sure about, right? And this you can learn only by giving mock interviews, or what we discussed today. And he said interviews, the system design questions are like so simple. Even most of the time, even the interviewers themselves wouldn't know what the actual answer is, because so it's very easy. Once you do the mocks, you figure out what the framework pattern is, you're done. You will be able to crack system design easily, because most of us, right, we are really scared about, oh my god, I don't know what how hashing function works, how top any things, this works or that works. That's fine. If you know the pattern, you're done. You can easily do that. That is what he said. And system design, like when he gave the interview with their firm, he got like all strong hires. And he said, just give some 6 mocks, you'll be done, like prepared for system design.
So even to give that mock, Ankur, like, see now, because I've listened to this crawler once, I can start and go in that direction. If there is some system which I have not seen before, how do I go about?
That even I don't, even I have to learn how to
It's
do
a
that.
question of, you know what the building blocks are. How do you chain those building blocks together to build something you want?
I think, for example, Sue, give an example. Like
the last time I told you, right?
some top
in
and
the top, and elements of the last one. It is not just top and at any time. It's like of last one, or how do you calculate? How do we?
But I think before, how did you start the interview? What did you ask him or her? How did you start the interview?
Like I started with the naive way of like with going from database like a single
No,
server.
but when he told you top K elements of something, what did he exactly say? Like
the exact question, I mean, all the requirements are clearly given to me. I have the question. Let me give you.
I mean, first it's like system design, right? You'll have to ask what exactly the interviewer wants. What exactly he wants. You don't want to be building something that he didn't even ask. I think that itself will like take.
That's the point VT was trying to make. You want to lay out your requirements, right? Make sure you have the requirement. You're discussing the requirement for a bit. Otherwise, you're going to implement something which he didn't ask.
Yeah, and imagine joining the company and then you spend three months designing something, making something which is not even required. So that is what they try to judge you in the system. And so basically, spend 5 to 10 minutes. If you don't know how to design it, just spend 5 to 10 minutes in understanding what exactly they want. Maybe then you'll figure out what to make. This is what we do in algorithms also, right? So I think last time what we resolve. So basically, we didn't know like the minimum heaps thing, that minimum meeting rooms. So by doing all those analysis, right, like what exactly is required, we were able to figure out. I was able to figure out exactly, okay, this is how we'll do it. So that's and this is something that we have to learn actually. So I think I'll stop. Anyhow, I'll stop the recording actually, because we are done with the crawler. Are there any more doubts on the crawler? Ask away to Devin. Okay. Pause.
Thank you for the session.